Extraordinary claims require extraordinary proof, so here we go. As this is only day 0, we've still got about 7 days left, so here's the magnetometer readings. It's a great app, Physics Toolbox. This is the magnetic field outside the room. And you can kind of hear the frequencies playing in the background from the device running.
At this point, I'm standing directly in front of the machine, and now I'm going over top. And now I'm pointing the device north. And south. And east. And west. Okay, now we're going to move on to the light meter.
This is just samples from the light source, so I have a piece of Arcamite charging that's embedded with a radioactive piece of neptunium. And it's just being charged with photons right now, and it's facilitating the reaction through the coupling box, the silver one that you saw there with the conductive tape. And here we just have a measurement that's basically the sound intensity or the loudness of sound measured in decibels. As you can see, it's got quite a range. It dips down quite a bit below 60 decibels, which is pretty hard to hear when it gets down way below 60. And now we're just looking at the oscilloscope readings here. As you'll be able to tell in a few seconds, it's going to straighten out. And that's actually the frequency switching over to a different bandwidth of the broadcast, as it is designed to broadcast on multiple sweeps. So that's why that happens. And I'm just talking, that's why the oscilloscope's going all crazy like that. And here again, we're just looking at the spectrum of sound. We can see there are actually some sounds that are very, very low. 1640 hertz is not very high. And we have a lot of sounds in the almost minus 36th range of decibels, which is very, 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 very low. It's almost well, not quite infrasound, but it's very low. And now we're just switching over to the spectrograph. And here the device was actually running, and then the spectrum sweeper kicked in at just the right moment. So here's the regular spectrum. And we should see the switch right now. Yeah, there it is. And you still have a little bit of sound in the background. It's a little bit more pure frequency at a higher amplitude, if that makes any sense. So here we go, and we're just showing that. And now we're just going to switch over here to the AR, or augmented reality.
Now we're just going to map out the actual
that'll actually give us sort of like data plots of the magnetic potentials hanging around. I'm actually doing like measurements. You need to be quiet, please. So here we are outside of the room. Again, I'm sorry for the mess. I just moved my entire office like within a few days. And here we go. Here's all the magnetic potentials lining up outside the door. We're kind of going in towards the door. So there's the device there, and we're just moving towards it. And there you can see the neptunium core. And now we're just going to do a little quick sweep here and see where the potentials line up. And as you can see, they seem to line up pretty good from north to south, at least as far as the device orientation goes. And up that cable at the window is actually an antenna that's broadcasting. I'm going to actually include what that sounds like a little bit later in the video here. But it's all very important. These computers are both running 8 radionic softwares, Mini Manifester. It's a great simple program, very easy to set up, and works very well with the type of witness samples that I generally use. And again, just getting a more fuller idea of what's going on in terms of magnetivity is really important. And the magnetivity is really important because the orgone tends to absorb it very, very well, and also emits it very, very well. So it actually sort of like a super saturated solution in chemistry where it becomes so overloaded that it can't stop absorbing it because of the bions. The bions love energy, and so they'll actually start to really pump out a lot of orgone energy because of the super saturation effect. It's pretty cool, actually.
The preliminary measurements. Now
so
we're
as you can see, like the
radioactive
magnetic potentials are pretty dense above it. And here's the radiation.